In this video, I'm going to show you how you can generate a dynamic mesh inside of PCG. So right here, I have a building that I'm generating using PCG, using the spline, and I wanted something to cover the top of the building. So I'm using a dynamic mesh generated with geometry script. So the PCG is generating the building itself, and it's generating a spline at the top of the building, and I'm using this spline to generate a dynamic mesh in the same shape. And if I make any changes, this dynamic mesh will update along with the spline. And we also have a lot of parameters that we can use to control the dynamic mesh. So we can move it up and down. Let's move it up so that we can see the full mesh. And you can inset or offset the mesh. Let's try offset it. And of course, you can choose the material and you can scale the UV. Now, if I switch to lit wireframe, we can see that the geometry script is placing a vertex at each control point of the spline. So it does not have a lot of triangles. So that will also mean that it will perform really good. And this is very easy to do. And it's very useful to make dynamic meshes using PCG. Now let's see how this works, starting by the PCG. So in the PCG, this is where the flat roof is being generated, and it's taking points, and these points are coming from this. I have a bound modifier right here. The bound modifier will just make the points larger, just so that we can see them easier. And let's lower the roof so that we can see the points under it. After that, I am using the add node, and I'm adding from a parameter called roof vertical offset, and that's what I'm using to move the roof up and down. And I'm adding this to the position Z, and that's will allow me to directly move the points up and down, because the output of this node is going into the branch. Now the branch will allow me to enable and disable the flat roof using this parameter. And from the branch, we are going into the custom node that is making the dynamic mesh. Now this custom node is basically a blueprint of type PCG blueprint element, and to make this, what you need to do is make a new blueprint and search for PCG blueprint element, and you can give it a name. And inside of the blueprint, you will need the three functions. That is the execute with context and point loop body and the node title override. And the node title override will allow you to rename the node. So you can rename it something like flat roof. But I already have the blueprint ready, so we're just going to use this in this tutorial. Let me just disable the debug in the PCG and start with the blueprint. Okay, starting with the blueprint, first thing we will do is get the input labels, and that will output a set of names, and we only have one input. The other inputs you see right here are the variables. The variables will allow us to enter values from the PCG, and they will be an attribute set. But for the first input, we're going to convert it to an array, and we're going to get the first item. The first item is going to be the points, which is the only input we have in the node. Now, after we get the first input label, we can use get inputs by bin label. The get inputs by bin label will take the input of the node. Now, the way that the data is structured in PCG, we have a PCG data collection at the start, and inside of the PCG data collection, we have an array of PCG tagged data, and so this will output an array of PCG tagged data. Now, the input on this node have only one data set, so that's why we take the first data set, which is the only data set we have in the input, and then we're gonna break the PCG tagged data, and that will give us an access to the data, and the data that we want is points, so that's why we cast to PCG point data. Now if it found point data inside of this input, it will set the data into a local variable so that we can use it later. And if it did not, it will end the blueprint and it won't output anything. All right, going to the next part, we have a point loop, and we are using the points that we just got from the input, and the point loop will loop through each point, and that will happen inside of the point loop body. Now in the point loop body, we are breaking the PCG point, and that will allow us to access different information in the point. We want the transform of the point, and inside of the transform we have the location of the point, and that will allow us to add a vertex at each point. Now we are subtracting the location from the actual location, and the reason we're doing this is because the dynamic mesh will be placed at the actual location. If you don't subtract the actual location, the mesh will be offsetted by the actual location. Now next, we are making a variable called flat roof position, and we're adding the location of each point to this variable, and that's basically it. Now going into the next node, we have get global mesh pool and request and release compute mesh. Now this will make a dynamic mesh, and you can see the output is dynamic mesh. So we're going to set this into a local variable so that we can access it later. Now the first thing we have is Append triangulated Polygon 3D. And now this is taking the flat roof position array that we just made in the point loop body, and it's taking the created mesh that we just made in here. Now because the points we are using are from a spline, the points are in the correct order, and we also went through point loop body and we've added the location of each one in order to this array. So this node will go through each one in the same order, and it will make a polygon, and this is basically the flat mesh in the shape of the spline. And so this is how we made the mesh, which you can see it's very simple. Now the next node isn't actually necessary, but if we have a point that is in the middle of a straight line, this node will simplify this point and it will ignore it because it's not necessary for the shape of the polygon. And there is an angle threshold of 2. So if the point is making an angle of 2 or less, it will be deleted. Okay, going to the next node, we have apply mesh inset offset faces. Now this node is what allow us to make the mesh smaller or bigger by either inset or offset the mesh. And you can see that we have a variable right here. This variable is accessed in the PCG, which is right here. This is the variable, and we can access it using a parameter in the PCG. And you can see that we're multiplying it by -1. And the reason is the default, if the value was positive, that's going to inset the mesh. And if the value is negative, that's going to outset the mesh. I've multiplied by -1 so that when it's negative, it will inset the mesh, and when it's positive, it will outset the mesh, just because the negative value will mean smaller and the positive will mean larger, which make more sense for this case. Now, in order to explain the next two nodes, I'm going to show you the output of this without the next two nodes. Let me enable let wireframe. Let's also move it up so that it doesn't intersect with the trim under it. Now here you can see that we are using a positive value in the roof offset, and that will make the mesh larger, and it will generate another mesh for the area between the old mesh and the new mesh. So this area right here, there is a mesh with a different UV scale. So this is the new mesh that is being generated by this node, and you can see that we are giving a polygroup number of 1 for the new mesh. So what we're going to do is we're going to keep the old mesh and we're going to delete the new mesh. And the same thing goes for if we have a negative value, and that's going to be for the inset. You can see that the mesh itself right now is in the same size because it's generated a new mesh outside, and the old mesh now is smaller. So we want to delete the new mesh. So in both cases, for the outset and the inset, we want to delete the new mesh because in the outset, it will overlap with the old mesh, and in the inset, the new mesh will keep the mesh in the same size, which we do not want. So the new mesh is given a polygroup number of 1, and the old mesh have a polygroup number of 0. So what we'll do is we will select mesh element by polygroup, and we will select the polygroup number 1, and that's the mesh that generated by this node. We will delete the selected triangles from the mesh. So now if we enable these two nodes and compile, we can see that the new mesh is deleted. And when we outset, also we don't have the overlap between the old mesh and the new mesh. So that's what these two nodes are doing. Okay, next we have scale mesh UV, and this is straightforward. This is just to scale the UV so that we can make the material larger or smaller, and we have a variable, and of course we can access the variable from the PCG, and we have a parameter in the PCG so that we can control the UV. Next we have the output part, and in here we are using construct PCG dynamic mesh data, and that's the node that will allow us to have dynamic mesh inside of PCG. And we are setting this to a local variable, and we are initializing the PCG dynamic mesh, and we are adding the mesh that we just created to the PCG dynamic mesh, and we're adding a material, and we are using discard global mesh pool, and this basically will clear or destroy the current global mesh pool, and the global mesh pool is what we used to create the dynamic mesh right here. So we are clearing this mesh pool because we have already added the mesh into the PCG dynamic mesh. So the last thing we do is we organize the data back. So the PCG structure the data by PCG data collection first. Inside of the PCG data collection, we have an array of PCG DAG data. So in here, we are adding the PCG dynamic mesh into a PCG DAG data, and we're making an array. The array only have one element, and the array is going into the PCG data collection. So that's what we can output back to the PCG. So that's the output that we have in here. And the last thing we have is a spawn dynamic mesh, and this will make the dynamic mesh appear in the level. So as you can see, this is very simple. This is what I've used to generate the dynamic mesh for the flat roof, and I've also used it to make this gable roof and the hipped roof and the hipped roof with diodes. Let me know in the comments if you want a tutorial on the hipped roof. This is a bit more complicated than the flat roof, but we can also make a tutorial on this. But this is it for this video. Thank you for watching.